Mr. Townsend, did you enjoy your snow days?
I did not.
You didn't?
No.
Why?
Because I'm just sitting in the house cold. What did you do?
It's free days.
There's no such thing as free days.
What?
Said there's no such thing as free days.
Or I can't, like, download.
Jonathan.
Alright, welcome back. We got quite a bit to look at today, so to try to limit your homework here, let's go ahead and get going. I did ask you guys to turn in number 77 into Google Classroom, so if you did not do that, this is your last chance to get full points, and especially with the snow, you may not remember. Okay.
Okay, so that's it. There's no more of those.
All right, so we need to quickly talk about the first and second fundamental theorems of calculus. So as their names suggest, that's pretty important. You actually know one of those two already. You just didn't know it was considered a fundamental theorem of calculus. And the second one actually makes some questions pretty easy to work, very, very fast questions. So you need to be familiar with that. And then we need to start off with that because then we're going to do one practice FRQ on accumulation, and we will need that in part of that. Then I've got a book assignment for you to practice some more anti-differentiation, and we're going to start with the end of that assignment because the end of that assignment is going to refer to the second fundamental theorem of calculus, which I'm about to tell you. And then finally, if you have time to get to it, I'm going to ask that you do at least half of the review, which is the last 2 pages you picked up, because next class is our last full class before this assessment. So I know the snow has kind of broken up our days a little bit here. My B-Day class is a little bit further behind, but if you remember when we came back in January, I warned you guys that this is kind of the tough unit, and the snow is making it a little bit harder, but unfortunately I can't do anything about that. Y'all have to step up here. Alright, so first and second fundamentals of calculus. We've got these definite integrals that we talked about last time. Again, some of this we've already talked about, so I'm going to do it pretty quickly. And basically it just tells you to do the antiderivative. So, raise the power by 1, divide by the new power, check by taking the derivative. Raise the power by 1, divide by the new power, check by taking the derivative. Raise the power by 1, divide by the new power, check by taking the derivative. And remember, if it's an indefinite, you're not going to have upper and lower bounds here. You're not going to have limits of integration, so you have to put the C. So that's not the focus of this, that's just a quick little reminder. The first fundamental theorem of calculus specifically tells us how to deal with definite integrals. And so I've already told you this, and you've already practiced this, but I didn't tell you it's the first fundamental theorem of calculus. So that's where you still do the anti-differentiation the same. Raise the power by 1, divide by the new power, check by taking the derivative. Raise the power by 1, divide by the new power, check by taking the derivative. Put the plus C if you want to, but if we have upper and lower bounds, also known as limits of integration, we can do this little bracket thing here. Put the number 0 and 2 to indicate we have not evaluated those yet. And then all the first fundamental theorem of calculus tells us to do is how to deal with this. So we plug in 2, get a number, plug in 0, get a number, subtract those, and you've got your answer. 6, I think that's 14/3. 6/3 plus 8/3 would be 14/3. Okay, that all looks familiar, correct? Okay, so for your AP test, you don't even have to know that this is referred to as the first fundamental theorem of calculus, but for your just calculus understanding, it's good for you to know that that is considered the first fundamental theorem, how to deal with a definite integral like that. You've already practiced it. Of course, more practice is good, which is why I have a few questions assigned to you. All right, before I show you the second fundamental theorem, I need to squeeze this top again because this will show up in a couple questions in your book assignment. If you would like to know the average value of something, this is more in line with the slope formula. If you know the value at the end and you take away the value at the start, that's like rise, divide that by how much of a run you have, where you end, subtract where you started, that computes your run. That's how you can figure out the average value. It's going up a certain amount over this amount of time. Oh, I'm sorry, that's not correct. This is not average value. This would be the average rate, because I would be thinking about the slope. Sorry, this is not slope. In fact, it probably would have been good to put an X to that because it's so similar. I just glanced through the reading too quickly. So in this case, what we can do to find the total value is we can integrate from -1 to 1, because what this does is it takes the value at -1, it takes the value at 0, it takes the value of 1, and everything in between and adds them all up. So that would be the total value. And then what do you normally need to do to make it be an average? How do you find the average of something? Okay, so in this case we will divide by the amount of horizontal distance we have here. If you call this B and A, you could either say B minus A, but over a horizontal distance of 2. So in this case we would divide by 2. So again, the first mistake that I had, this is kind of good that I made this mistake, but if I wanted to know the average rate, I would do the slope formula because it tells me where it stopped and ended, so I can figure out how much it rose over how much time. But if I want the average value, this gives me the total value. It adds up everything from -1 to 1, and then if you want average, you need to divide by how much horizontal distance you're traveling. Just like if I was doing an average score on a test in here, I would divide by the number of students. Got to divide it into number of pieces. Okay, so second fundamental theorem. We're going to work this out the long way one time, but these questions should be almost instantaneous. This question is asking us to take the derivative of the integral of this stuff, and it has an x here and a constant here. All of that is part of the second fundamental theorem. So let's say we don't know the second fundamental theorem of calculus. What we could do is we could do the antiderivative, raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Raise the power by 1, divide by the new power. Checking each time. And we need to evaluate from x to -3. So I'm going to worry about this derivative at the end. It's on the outside. So if I first plug in x into all of this, normally you plug in a number and you get a number. If you plug in x into all of this, you're going to get all the t's become x's. So that's what it looks like when you plug in x into all of that. And then I'm going to subtract what I get when I plug in -3 into all of that. And I'm just going to do it in my calculator to save a second, but it doesn't really matter. This is -1.5. Okay, now we can worry about the derivative part. What's the derivative of 1/3 x cubed? Okay, what's the derivative of 3/2 x squared? Derivative of this, somebody else? 2. And the derivative of this? 0. That's why I said that this didn't matter, really. I plugged it in to see what it was, but it didn't matter, because the derivative of the constant is 0. So our answer to this question ended up being x squared plus 3x plus 2. You really are supposed to know that answer without doing this mess of stuff. This is way too much work for what we need to do. What the second fundamental theorem of calculus says is if you take the derivative of an integral and the bottom is a constant, so if you're plugging in a constant, this gives you some number, but then when you take the derivative, this goes to 0. This essentially just gets plugged into all of this stuff. T squared became x squared. 3t became 3x. 2, there was nowhere for x to be plugged in, so it just stayed 2. We can go straight to that answer because derivatives and integrals are inverse operations, so it's almost like these two are just canceling each other out. As long as the bottom is a constant and this top is a variable like this, you can just plug the variable in to those. So I don't want to do the long way all the time, so on the back page we're going to go quickly on here to show you how fast this can be. The derivative of an integral, if the bottom is a constant, and just for mathematical sake here, let's change these to t's. They really shouldn't be the same variable. Change those to t's. You're welcome to integrate this, then plug in x, then plug in 1,000, and then turn around and do the derivative, but you're going to basically undo most of that. So in the end, all that's going to happen is this x is going to go in place of this t, in place of that t, and you can try to plug it in here, but there was no t on this one, so those two are just canceling each other out. We don't need to do it the long way. We don't need to do the integration by hand and then turn around and do the derivative by hand. Okay, so let me say that again. Again, change these to t's just because the variables shouldn't match up. The derivative of an integral, if the bottom is a constant, you can just plug this x in everywhere there was a t. And you get x to the 31st minus 9/11 x to the 5th minus 70. That's all that happened, even though we did this manually. The bottom was a constant, x squared or t squared became x squared, 3t became 3x, and 2 didn't have anywhere to plug in the x, so it just stayed a 2. That's all we're doing, but we're skipping all of the work. We're recognizing this pattern. Okay, this one, t, make these t's. Okay, the bottom needs to be a constant for it to be the second fundamental theorem of calculus. So the derivative of an integral, inverse operations, these are basically canceling each other out, except this gets plugged into there. So instead of f of t, it's going to be f of x. The t's become x's. That's basically it. Okay, and then if we want to know specifically when x equals 2, that's just going to add one more step at the end. The bottom's a constant. Again, these need to be a different variable other than x, since I'm plugging in x. In mathematics, we can't use x for two different things. This basically cancels out this, but instead of t cubed, it's going to become x cubed. Instead of minus t, it's going to become minus x. And you can try to plug in x here, but there's nothing to plug it into, so it's going to just stay at 1. And then if you need to know when x equals 2, just plug in 2. Final answer to that would be 7. So there are times, like the bottom of the front page, where you could manually do it by hand. You could integrate the inside part, get an answer, turn around and take the derivative, and you're basically undoing most of your work. But occasionally you'll have questions phrased in a way where you have to know this. So it's not difficult, but you need to see that pattern. Okay, are you guys okay with that before I show you the one other part of this? Okay. The only catch to this is sometimes there's chain rule. So, derivative of an integral, the bottom's a constant, so this is the second fundamental theorem of calculus. So, you can go and plug this in. X squared plugged into x to the 4th becomes x to the 8th. X squared plugged into 5/12 x squared would give us 5/12 x to the 4th. And you can try to plug in x squared here, but there's no x's. Well, these should really be a different variable like t. But you try to plug x squared into this, there's no t to plug it into, so it just stays 1,000. The only thing that you have to also consider with these, with chain rule, is this derivative of the upper bound. If the derivative of the upper bound is not 1, like all the other questions on this worksheet, you need to multiply all of this by his derivative. So there needs to be a 2x there. And this is a very common question type. And of course you can do chain rule, so it's just a matter of putting it part of your thought process. Okay, derivative of an integral where the lower bound is a constant. I know this is second fundamental theorem of calculus. Again, these variables are going to be different. That's just a typo for me. So I know that these are basically going to cancel each other out, except this guy's going to get plugged in everywhere there's a t. So we're going to end up with x to the 93rd minus 9/11 x to the 15th. X cubed to the 5th becomes x to the 15th. And then you try to plug it in here, but there's no variable, so it stays minus 70. The last part of this is you still need to multiply by the derivative of x cubed, which would be 3x squared. Up above, I'll put this back in a second. Up above, I didn't need to do that because the derivative of the upper bound was 1. Derivative of the upper bound was 1. And of course, multiplying by 1 doesn't change anything. So we don't need to do anything if it's just an x or just a regular variable. But if there's x squared, x cubed, we need to multiply by his derivative. Okay, I would like you to commit yourself to an answer on number 3 before we discuss it on the board. And then maybe that'll help you see if you need to ask any questions or write yourself any notes. And then we need to move on. did you end up with f of 2x squared? Is that part of your answer? Okay, because again, this really just gets to get plugged in there if it's set up this way. And you should have also had uh, 4x because of chain rule. Good with that? So again, I don't like you to just try to memorize patterns, but this is the second fundamental theorem of calculus. Your AP exam and some of your exams for us, there will be questions like this where this should be about a 5-second question. You plug it in, or you recognize the pattern, you plug it in, you multiply by the chain rule if necessary, and you move on. All right, so the next one I want to look at is this accumulation FRQ, and you're going to see that this does, what we just talked about is going to show up without them mentioning it. This FRQ is actually from 2005, FRQ number 2, and this is calculator allowed. But you don't need a calculator right now. If you don't have one out, don't worry about it, because I've already done the calculations. I'm more worried, you guys should know how to type this stuff in the calculator now. I'm more worried about you understanding the conceptual how to set this up. So this is a very, very, very common type of FRQ. This will be one that we will, if we don't have too many more snow days, we will practice this type of FRQ several more times. This is called a rate in, rate out. It is one that they ask almost every single year. And your AP exam has 6 FRQs. So if you really prepare well for rate in, rate out questions, and you get lucky and they ask it again this year, like they ask it most years, then that gives you a little bit more confidence, gives you a little bit more breathing room on some others that may look a little bit more foreign. But this one was about sand, and we have a rate that it is being removed from a beach. That's the rate out. And the rate is being added to the beach. Rate in, rate out. Both R of T and S of T have units of cubic yards measured in time from 0 to 6. At T equals 0, the beach contains 2,500 cubic yards of sand. All right, part A. You don't need to get out a calculator or anything, but I want you to think about how much sand will the tide remove during this 6-hour period. I want you to take 10 seconds to think about what would your process be. And a lot of times in calculus, if you don't know, remember calculus really boils down to limits, derivatives, or integrals. Of course, they squeeze in some algebra too, but okay, the most common wrong answer here is to say, I'm going to plug 6 into R. What does R of 6 represent? Okay, it's the rate that sand is being removed exactly at time 6, right? That's not what we want to know. We want to know how much sand is being removed during this 6-hour period. So how much is being removed at hour 1, hour 2, hour 3, hour 4, hour 5, hour 6, and everything in between. We can't add those things up manually, so the next best thing is to say integrate from 0 to 6. That's how you get the total value. That's going to calculate the total amount of sand removed. Just so you know too, on your AP exam, you're welcome to write the 2 plus 5 sign of blah blah blah, but since they've defined it as R of T, you can just write R of T also. In fact, that's probably preferred, because if you miss a letter or miss a number, your answer would be wrong. Okay, and our calculator, this was calculator allowed, so you could type this in your calculator, get an answer, and you would get either this or this. Remember, your AP exam expects 3 decimal places. They don't care if you round to the nearest thousandths place or if you truncate, so they will accept either one of those. But I think you had to have both parts of that to get that point. So integrating 0 to 6 is how we add up all of the time from hour 0 to hour 6 and everything in between. R of 6 would only tell you the rate at exactly hour 6, how much is being removed. Okay, you guys okay with that? Okay, then part B. Write an expression for y of t that represents the total amount of sand at the beach for time t. So, how are we supposed to know how much sand is on the beach at any given time? Do we know how much sand there is at the beginning? Okay. So we can start off with our starting amount. And then again, I know you guys had a little bit of a break in between, but the integration keeps up with how it changes. So if I figure out how much sand are you adding from 0 to 6, and then take away how much sand you're removing from 0 to 6, do you understand why this function tells you the total amount of sand? What you're starting with, how much has been added, and how much has been taken away. Except one part of this is incorrect. And this is the most common mistake here. 0 to 6, it's always going to add how much sand is being added over 6 hours. 0 to 6 is how much sand you're going to remove over the 6 hours. This doesn't say over 6 periods. It says at any time t. So at any time t, I don't need these to be 6. I need them to be for whatever time I want to know there to be sand. If I do 6, it's only going to tell me that one instant at the very end of 6 hours. Changing that 6 to a variable makes it dynamic. Now if I want to know 3 hours, I make t be 3, and I can figure that out. So, again, you need to phrase it this way in your head. Starting amount plus how it changes. Integration is how it changes. This is adding, this is being removed. That's why I subtracted there. You guys okay with part B? Okay, I have to keep going if y'all don't say. You need to advocate for yourself here, because I can't just sit around and wait for y'all to decide to ask. Okay, find the rate at which the total amount of sand is changing at t equals 4. So I want to know the rate at t equals 4. Well, rate is derivative. So they're saying, what is the derivative at time 4? What's the derivative of 2,500? Okay. What's the derivative of the integral of 0 to t of s of t dt? It is just s of t. That's the second fundamental theorem of calculus. If you're taking the derivative of an integral and the lower bound is a constant, you get to just plug this in. So I already had it as t. I think on the answer guide they actually make this x to reduce that confusion. Okay, minus what is the derivative of the integral of 0 to t of r of t? It's just r of t. This is where the second fundamental theorem is supposed to help you out. Taking the derivative of an integral if the bottom is a constant should be a 5-second question. You really need to highlight that so that you remember where that came from. Second fundamental theorem. Okay, so if I want to know y prime of 4, I want to know at 4 when t is 4. So you could plug 4 into this in your calculator, get a number, plug in 4 into R in your calculator, get a number, subtract those. Your calculator can do the rest of the question. It comes out to be this or this, depending on if you round or truncate. They accept either. That's the numbers you should come up with. On this question, you only get the point if you got the answer correct. So the rate is how I knew derivative at 4. That's why I plugged in 4 at the end. But to take the derivative of my function from part B, I had to know the derivative of constant, and then second fundamental theorem, second fundamental theorem. It's very easy if you know that piece of information. And if you don't know that piece of information, you're pretty much done. Okay, part D. What time is the amount of sand on the beach a minimum? So as soon as I hear minimum, I'm thinking extreme value theorem from last semester. Extreme value theorem told us the max, absolute max, and absolute min is going to occur at either an end point, like 0 and 6, or a critical number. Well, how did we find critical numbers last semester? Okay, so we need to figure out where the derivative is 0. They give you a point if you indicate you realize that. So I just did the derivative right here. I ended up plugging in a 4, but the derivative of y ended up being s of t minus r of t. I'm not going to go through that again because that's what we did right here. It was 0 plus, but who cares? So if I set 0 equal to this, this is where your critical number comes from. So you can either, you'd want to use your calculator here. You could either use equation solver or graphing. You could either add this over and figure out through intersections where s of t equals r of t, or you could graph all of this and look where it hits the x-axis, but you need to be able to solve that with calculator. Again, I'm not interested in practicing that right now. That is when the derivative is 0, so that is the critical number. You get a point if you found that. Okay, so now to identify when and what the minimum amount of sand is, I need to find these values. How much sand is there if t is 0? 2,500. It was given to us in the directions. How would I find the amount of sand at time t equals 6? In part what?
Part B.
Very good. So understanding in part B, we wrote an equation that was determining how much sand there was. So if you plug 6 into this, into your calculator, and let it do all the integration and stuff, it would be a total waste of your time to do by hand, even if you could do it by hand. You get this as a number. You could also plug in the critical number into y of t to figure out how much sand there was at the critical number, which of course is when there's probably a max or a min. And extreme value theorem says test the endpoints, test the critical numbers. Now I can see at this time is when there's a minimum, and that many cubic yards is what the minimum would be. I'm just not writing it out in a sentence. At 5.117865 hours, the minimum amount of sand would occur of 2,493.277 cubic yards.
Would it be 6?
Yes. I'm sorry. At this time, that's a smaller number. So the mistake I was making there is 99% of the time on these questions, it's the critical number that's the max or the min. But it could occur at the end point. I was just in autopilot. Okay, there's a lot to this FRQ, but I need you to understand why all of this is the way that it is. So the 30-second recap. Integrating from 0 to 6 is how you figure out the total amount that occurs from 0 to 6, whether it's removed or added. Part B, we wrote a function for how much sand, and we used this the rest of the question. We had this much sand to start with, plus this is how it's being added over time, subtract how much is being removed over time. We figured out the rate of change at 4 by taking the derivative of y, using the second fundamental theorem of calculus and plugging in 4, and then the calculator does the arithmetic part. And then part D, wanted an absolute min, which means I need to use extreme value theorem, test the endpoints, test the critical number. I had the endpoint here, plugged in 6 into this to find the end number there. To find the critical number, I had to figure out where the derivative equaled 0, but I really had to do that for part C as well. So again, how to get from this to this, I'm just using my calculator, and I did that ahead of time so we could save a few minutes today. So I need y'all to speak up. Are you okay with the process on part A? Why the integration does what it did there? Okay, on part B, are you okay with why this function represents the total amount of sand at any given time? Okay, in part C, are you okay with how I did the derivative using the second fundamental theorem? Okay, and then in part D, do you understand why I tested the endpoints and the critical number? Okay, and to be honest, I don't know what type of FRQ we're going to pick out for our next test, but I would not be surprised if it was one similar to that, because rate in, rate out type questions are very, very common. So that's a good one. Okay, moving along here, I've got a book assignment, but I want to do the first handful of questions with you guys. So for now, go ahead and number a blank piece of paper 80. Write that assignment down, and then we're going to jump to the end, 87 through 97. Quickly, please. Okay, and I have cut this book assignment down in about half so that it should be achievable to finish in class. And it does look like a lot of questions, but 87 through 97 should all be very quick. We're going to knock out like 10 of them in just a minute. Actually, I'll just put the assignment back up in a little bit. I'm not going to wait for the slowest people. You don't have to write down the question unless you think that that would help you. Might be a good idea for a question or two. But 87 gives you a function, and it looks like it wants capital F. So what is the answer to this question? One more time.
X squared minus 2x.
That's it. We wanted the derivative of the integral where the bottom number was a constant. This just gets to get plugged in here times chain rule. But chain rule of the upper bound in this case would be 1. That should be a 5-second question. Okay, so go ahead and keep going. Do 88, 89, 90, 91. I'm going to give you a minute head start, and then I'm going to write out all the answers for you to check. Okay, I'm just now starting, so I should not be beating any of y'all. Okay, I'm done with all of them. Using the second fundamental theorem, if you really know it, should take you that long. Taking the derivative of an integral where the lower limit is a constant, you get to just plug in the upper bound everywhere there's a variable. The t's become x's, the t's become x's, the t's become x's, all the way through. The last three had one step of chain rule. I'm not doing any special shortcuts. If you understand the second fundamental theorem, you should not be taking a much longer time than I just did.
Should 97 be?
Oh, I'm sorry, which one?
97.
Here. Oh, actually, I did lie though. Were you saying this should be 3x squared here? Yeah, thank you. That was just an honest mistake. I did lie on two of these. Two of these are wrong because two of these are not second fundamental theorem. which two would that have been? Christian, you need to.
93.
Okay, what was wrong with 93 and 94?
They had X for this time.
Right, their lower bound was not just a constant. So that's not, you'd actually have to work those two out by hand. So cross off 93 and 94. You don't need to do those by hand. I was just glancing too quickly. But the others should be fast. Now, this will be on the test as a question. And I will tell you, this is usually in the more missed questions. This does not take but a good 30 seconds of reviewing for you to be able to get this question right. So I don't know how else to help you with that, except to give you a worksheet with 100 of the problems and just try to drill it in your head. But you need to know that because it's meant to make your life easier. Okay. All right, before I move on from that, is there any of these you guys want me to talk about in detail? Okay, then here's the rest of the assignment. It's like 12 questions. So again, I cut this down to about half of what it used to be. So we're going for quality over quantity here, but I was trying to give you an amount that you can do in class and get help with in class, and should not need to do any of that for homework, because for homework I need you to do half of the review. Obviously, if you get to the review in class, that is great. One thing I'm going to specify though, even though I don't care which half of the review you do, I do want you to try it in order. So try question 1 before you try question 2. Try question 2 before you try question 3. That way, when I see you guys on Monday, you will know if you need help with question 1. And you will know if you need help with question 2. And that will help us, that will help me help you get more help before the assessment.
Do you like Star Wars, Mr. Johnson?
Now's not the time, Christian. You got too much to do. So within this, there's a couple average value questions like we saw in the notes. There's a couple questions about finding area under a curve, which is what integration does. It just phrases it in a different way. There's a couple where you're trying to just antiderive through a definite integral. So you've done that before. Just get in some practice and getting a little bit more comfortable there. And then I think that's about it. You should be about done after you do a couple of each of those. I will obviously come around and help in just a minute, but y'all should be okay to start off.
Yeah, that's how I think you're doing. That's how I'm doing it.
Yeah, because it's just.
This is the first thing. This was your review. And then plug it into that minus.
That's weird.
You and one. Sorry. What is this anti-derivative of the square root of the?
Because you turned this into like.
Bro, you're smart. You carried me last year. You carried me last year.
Just so we plug in the top. The bottom. Yes. So if you plug in 0, you get -1 total. Minus.
What over
-2 minus 2. No. -1 minus -2.
You're bad.
I just don't change those.
What is the anti-derivative?
Oh, that, I see what you're doing.
Well, they changed the square root of u to the 1/2. What's that like? Raised to the power by 1 divided by the new
Yeah, I
power.
got it back.
So to the 1/2, and raise the power by 1, which equals to the 3/2.
So one, yeah, one. And then
Divide by the new power. Divide by the 3/2 is the same as multiplying by 2/3. So 2/3 you do the 3/2. And then check by the 2/3.
I think I'm. Did you get one?
What was the thing? What was it wrong with that?
Whoa, you're flying. Oh, never mind.
Oh, I didn't.
Yeah.
Get your own. Don't need help with the first couple yet?
So that, no, it makes sense. So because the square root of your bottom. Yeah. That would be.
A couple of these you may want to rewrite before you do the antiderivative. Just like derivatives, sometimes you want to do fraction step or an algebra step before you do the calculus step. You'll need help with the first couple.
I'm going slow.
Don't forget, you can also check these in your calculator. I know most are odd, so you could check them back and forth too, but it's good through your practice with your calculator. That's what I did on that accumulation FRQ. I just did it before you got here.
Oh, wait, I should have
That's
said
something.
that. I kept
I did not
that.
want to do that one.
Oh, wait.
Okay, so
Yeah,
I got.
Multiply by 2.
Yeah, that's what I thought. I like.
Because you divide it by 1 power, divided by 1/2 is square root.
Sine of 0 goes on 0.
Before I even did, I would split up my fraction. And then divide things
Wait,
with the
sine?
base. Subtract the
Oh, this is so annoying.
Wait, so it's 1 squared
Oh, yeah. 2
minus 2x
1 minus a half.
times.
And then rewrite And then I'll worry about calculus.
That's better.
Now we're going to try about one divided.
U squared is fixed line.
You should not just jump into the calculus on every question. If you can rewrite it to make the antiderivative easier, so that
Which would be, yeah. Of negative one, right? You have to increase the power by one, which would be equal to 1/2, right? And then you have to divide by the.
This is true. Are you writing this one? That's true. Yeah.
but you're gonna get stuck today. Well, you can maybe get it removed this. Right? That's basically what I did there. I just did it in a
So it's
different.
two meters.
Yeah. What you need to do is you just set it up to 245. Now, when I reduced the assignment today, I still tried to pick out the ones like that that I would thought might not be super intuitive to everybody.
Did you get 0 times?
No, I didn't even do the calculus yet.
Okay. It was just different than what I did. I was confused.
No, it's the same exact thing as your other except it's just like not square. Wait.
We never looked at it.
Yeah.
Well, you guys get 0?
Okay, so.
We didn't plug anything in.
It's your 2 0.
Because that's
Because you're subtracting.
that's ending. If you didn't plug it in, you made an error.
Yeah, right.
That's why.
Yeah, so would that be?
Yeah.
Square root of 2/2? And you square? Wait, is it square root of 2? Square root of 8.
Wait, yeah, 0 times 4 minus
No. Square root just means
1/2
bring the
times.
square root back up.
Square root of 2 over regular 2. Okay.
So did you get?
Square root.
Okay.
Wait, hold up. So there's so would it just be 2/4?
Dividing by 300. Also, you don't need to worry about like getting the exact perfect answer in your head. Just write it down on paper and then do the power rule, see if it works. I don't care about your time.
Wait, maybe 2/4.
It is, it's like amazing. Because it's like
Square, you're just multiplying square root of 2/2 times square root of 2/2.
No, it's in the middle of the onion, so it's like
I don't care about the middle of the middle pie. I don't care about the middle of your onion pie.
Do you actually not?
I think I want to.
2/4. So it'd be 1/2. Yeah, it's just like a long. This one's kind of weird. Just like lots of like little mini calculations over and over again.
Well, I don't know this, I haven't looked at this question, but 1 minus sine squared
Oh.
Wait, did
is
you
the
get?
same as cosine squared.
Oh.
So I think that whole thing just goes to 1. What it looks like on your paper, I just looked at the book.
I would end up getting some.
I think you're right.
So, you might come out with the same answer, but it's yeah, sometimes if you recognize those, it's the same as that, like, you probably could do that straight calculus wise, but it's so much harder than some of the other
Let's do some erasing.
You was messed up.
Yeah, I'm just gonna go erase them. Oh, okay. It makes sense, but I didn't think about it.
So,
cosine squared. Cosine squared. So you lost right?
Technically, this is correct, but this is kind of weird. Because it's divided by something, it's the same as so all of that is wait.
Because regardless of what it's like, it's the same. It was, yeah, it's, well, with no work, wouldn't it be 1 minus 1? Not 1. The answer is 1. So, yeah. Wait, is it in the back of the book? I'm gonna look in the book.
Wouldn't it be 3 half x?
Honestly, I don't know. Wait,
Normally I'm pretty good at doing that. This is how I do it.
Oh wait, we have it. Oh wait, that was.
this is 29 is pi over 4. What? Hold on. Pi over 4, right? 1 minus sin squared.
So when I look at this, I'm saying read yours, understand my right. And then I have
It should just be 1. Just write down.
So I got 3t.
What's this?
There has to be a way. So here's the problem. Is your calculator does word operations, so that it does its exponent first,
Double check.
and then it's multiplying by negative. What you really need is the whole thing.
Well, no, this is the right page.
Oh, yeah, I did turn it in on top. Just making sure. Actually, did.
Number 29. It says 27.
What does it say for that?
Oh no. 15 is 2 to 3.
It'd just be negative to a even power is
19 is negative
you
1
raise it to the 4.
Those have to all be there. Dude, there's no way. How is the world that we do it that wrong? Do you have to, I think you might have to integrate first. But I think you might have to. Well, because look what we did here.
I think I got my signs.
We did it here. This is all integrated. Well, that was, that's different. I guess this is.
Wait. So it should be
No.
-2 plus 3 or 4, which is going to be negative 1 or 4
Well, then where's the, We have notes on our
Okay, I was
We
right.
have to like choose.
If you do switch it, you get wow.
In what case would you add? So you can
Yeah, no, it says
You got 0?
to the. Because I did some mistake with this.
It was just your,
Everyone's waiting something.
it's literally just your sign.
Or should moving along pretty quickly. Each of the ones. Sign. I have to sign.
But you can move on.
Either one is me.
So for A,
I will split this up, just like I did that one earlier. So I put x over 3, or 1/3 x, minus
I think all of them.
Is your calculator?
x over 3 is the same thing as 1/3 times. So which, I prefer to look at it that way than right.
The sign of
And I do the
one
same
is just
thing
one
over there.
revolution around there.
Sign of I.
Oh, it's sign of pi. That sounds good.
So now raise power by 1, divide by the new calculus. So 1/6
Sign of one would be.
What do you mean it goes 2/3, right? Because it's like less than a third of I, which is like.
I mean,
She just told me that's why.
So what's the power on that?
Wait, no.
So raise the power by 1/3 can divide by 3/2.
Yes.
Okay.
Okay, now divide by the new power. So what's 1/3 divided by 3/2?
Watch, I'm gonna get the third.
Yeah, you probably don't know.
So let's give me that exponent. Derivatives. You're doing an antiderivative, so whatever you think the answer is,
I think that's
you
right.
do the power rule.
what's
Make sure that goes back to what you started.
That's just, I think it's just.
no, it's just after lunch.
So the sign of one. Oh, I got it. Yeah, this.
Right after lunch.
No, I just did sign of 1 plus. Sign of 1 plus C. Oh, that's why. You're not very one.
Did you get 2 x to the 3? You're not.
Yeah, okay, so there's that. Now we have 3.56. Minus. Now we want to negative 1.
Even the negative 1 is fine. Square.
Well, or no.
So you're checking them on the back too.
No. If you take the derivative of b, it's just e. So we need what we need to do is we still need to put it. So b.
No, like whatever, it's like, oh, like, I'm wondering what he's asking that thing. I'm like,
How did you get this? Wait, how'd you get negative? Wait, we did the first one. I think that first one was right. Yeah. 37.
Okay, so what can you take the derivative of the
What's the common, whatever it's called, it's 6 and 9.
Are you not doing the
You got
antiderivative?
1 6 minus 2.
Yep. It's all good.
It's gonna be 3 minus
So I'll just plug in on that one?
Yep.
I mean, that would be nice if it worked that way.
Yeah, that would be very nice. Skip the first step.
Yeah, I mean, you're basically not doing anything. You're doing everything but, you know.
I think it's pretty bad. No, it's fine. But then we have to do the whole thing.
We're making sure that our pages are is correct.
Where? Minus X.
We got negative 40. We got negative 20.
That's why.
Because then you guys do like weird like 1 6.
Yeah, it is. Okay. We should listen to the back of the book. I don't know why.
So I just go like this.
Come on, Mr. Johnson. I'm doing my math in my head and I'm getting my body.
I think you should do it less. Do it less.
That's too much writing. See, it takes up too much space.
Writing down steps. Tells you to manage how much you keep out.
This is right down the wrong way. Mr. Townsend, guess what mean you should do wrong?
I don't know, but comes at the end of class.
We should go to the basketball game, and we have lightsabers, and during halftime, we'll play lightsabers.
Yeah. Well, we understand the process now.
And then you just ditch the process halfway through.
What do you think I should do?
You have to remember 15. Okay, if you didn't hear me say, so I have some stuff written on that board over there. I rewrote it a bit before I did the
It's not
calculus.
even that funny. It's just like Star Wars and the only thing that
I don't expect you to know what you can say the derivative of to get 2 minus u over the square root of u. If you split apart the fraction, simplify it a little bit, it makes the antiderivative life.
That's so weird.
It's basically impossible to do the antiderivative.
like so good at math.
So I split apart the fractions and then I used the exponent rule. Nice. And I
I feel
did
like
the raise
it's
power by 1
actually
divided by
genuinely
2.
think that like I always think like everyone thinks that's for Oh my god.
I'm real, bro. That would be almost materialized for science. Are you thinking sine squared plus cosine squared is 1?
Yes.
That would be your trying to
We're such a
do.
dad.
Not good about it.
Oh, I thought you were fixing
My dad.
that. My suggestion to you is just write down what your guess is and then check it by doing the derivative. You write down negative cosine.
Oh, it's
make the
negative.
derivative of that it becomes something, so it doesn't.
On the actual test.
First two puzzles.
I didn't even get the Yeah, it was bad.
Yeah, just like, I mean, it's like, yeah, I just think it's way better than fucking loans.
One minus sine squared. Minus sine squared is something sine squared divided by cosine squared. Integrate one. Yeah, so that's a lot easier.
Would that be 1? So let's just get
That's fine. Just wait until you bring it up.
Oh,
Did you get the average value? Yeah, that's fine. That's all we need.
Oh, yeah.
Just so you know, if you know what the average value is, like the 20, you can set the function equal to 20. So like 9 minus x squared is equal to 20, and then you can solve for x and know when that's 6.
I heard some kid was doing work at
I thought you said negative cosine. It's for like gas.
And she bought like 5 directions. She was just
Change it.
And I was like, that's like how it is. She was like, this.
When I'm on my phone, I'll make sure it doesn't work.
It's actually kind of satisfying.
And it's probably texting me
That you just like code to window. No, but I guess we're less than right? I forgot his last name. No, I know why Isaac. When me and him were getting on the weekends, hey Isaac, came to another round.
Yeah, T to the 1.
It's not that hard.
It would be T to the 1
All you
there.
have to do is bring
Unless it was from the bottom.
Oh, I thought you were trying to
From the bottom to here.
He was going 3, 2. Isaac was like,
Are you like mocking me?
how am I supposed to know?
And I just wrote it. I think, right? Would that make sense? 1/4 is the, both of them are positive. I'm pretty sure they cancel out.
Mr. Townsend? How many times do you get called Isaac? Like, is that something like you just get called sometimes as an adult? Like by your first name? Or is that like a certain age where you're just like always called by your last name? You know what I'm saying?
It depends on the person.
Does your wife call you Isaac? Or is she like hubby or something?
My wife doesn't call me Mr. Townsend, if that's what you're saying.
Whoa, does she call you like hubby? No?
They're just like sweet. Like I don't.
I mean, I guess she doesn't call me. She probably just says, hey.
Your name is Henry.
I mean,
Wait, one half to like, I bet just put two.
Yeah. Sure. What's up? Why are we in
Oh, because the
Oh, I
sun.
know.
Okay, yeah, that's fine. It's only 5.
It's like minus negative. So
Oh yeah, I love that. What about
I got 3 over
we have 7. The X doesn't mean
We went back and said, I thought this was a constant problem, so I thought this was the second fundamental theorem of calculus. I didn't look at the question. That one should make sense, because you know it is. So like, if you want negative 1, the area of the above, you have to actually
No, I'm sick. I don't have the flu.
oh, that's where they answer.
Yeah, I had 1 of 3 fever like 2 days straight.
No, that's just
I was wretched. It was. And then I went outside to like run in circles and watch TV. But it wouldn't start until like. And then so it was like 9 degrees. So I went outside and I was ready for a big fire, but I made it. That and very cold, so I was stuck there, cold and wet.
I do, but I don't think we're gonna that would be a try to find it out somehow. Look, well, my is I have another sister.
I think you're on
And look, did you see it?
Somehow she manifested what the
She
literally so ignorant.
Alright guys, we got to about 3 minutes. Don't forget, I have, there's like 2 or 3 of these I don't have worked out on my website. But any of these that you need help finishing, you should look at the video on my website to get an idea of the hint and get you on site.
Well, this is tomorrow. That's okay.
I should have a little ball.
I would not get into this if I see
I'll get out. I'll get out.
Is Nat her with I'm scared of well, Trent really counts as like is he so bad? Because he's just so friendly.
It's confusing all this through people. Well, I have a problem. Maybe it's caused through.
That's really funny.